Hello everyone. Everybody got food and happy, so we can start, right? Uh, I will talk about SCADA vulnerabilities, and my main purpose of actually to show how it is easy to discover vulnerabilities in SCADA applications. Actually, I just researched and actually did basic research on SCADA applications, and the result was so amazing. With using basic techniques, reversing techniques, and vulnerability research techniques, it was very easy to discover vulnerabilities in many SCADA applications. We will see how it is easy. First, let me introduce myself. I'm a security researcher at SignalSec, and also I am organizer of a hacker conference in Turkey called NobCon. I am interested in breaking stuff, reversing vulnerability research. Basically, actually, I am just another guy who hunts software bugs and sell them for a living. That's all about me. So how it start? As we know, SCADA systems are all in their life for a long time, but there was not too much interest in SCADA security until Stuxnet and Duku cases, right? After that Stuxnet case, SCADA become more popular and got attention of hackers and researchers because we thought it can be profitable and it can give fame, and they are juicy targets as they are critical systems. So I know everybody here knows about Stuxnet, so I will not mention it again, I promise. So this is just a basic overview of the SCADA system. Oops. Yes. When I say control system vulnerabilities, I group it to two parts. Actually, we can say that there are two main parts of a SCADA system. One of them is HMI part, which is used by operators. That's called human-machine interface to manage and control the PLC devices. And so I call them hardware vulnerabilities and software vulnerabilities. When I say hardware vulnerabilities, I mean the bugs in PLC devices or firmware software. When I say software vulnerabilities, I usually mean vulnerabilities in HMI applications, control system software. So we usually see this kind of news on web at newspaper, 2,000 bugs discovered just in a few hours. But actually, believe me, it is really easy to hunt these vulnerabilities. That's not hard job. Why? Because there wasn't a real threat for SCADA security until Stuxnet case, and there was not too much attention. So the developers of SCADA applications were not aware of secure development practices. So these applications are really like a silly cheese. They have many holes, and it's really easy to discover. Let's hunting vulnerabilities. How I do it. Simple reverse engineering is very useful to discover these vulnerabilities. Before, that's useful for every application. If you want to hunt some vulnerabilities in applications, first we must know the application. We must analyze the target software. We must discover potential inputs, such as that can be communication protocols, or if the application reads a file is an input for the application, or ActiveX components. Every input can be a door to the vulnerability. So after we find the inputs, I try to trace the input and I try to see how it goes on, and then finally, I hunt the bugs. But you must understand that there are more ways to discover the bugs, as Miyamoto Musashi says. Let's start with a German SCADA product. It's costly and widely used in Germany, France, Italy, all Europe. It's a development environment for control systems. The costly framework also used in many other SCADA vendors. This vulnerability discovered by Aaron Portnoy is patched now. Let's see the vulnerability, how we can rediscover it. First, I installed the software on my computer and checked what it does, and I saw that it listens to the TCP port. So I tried to trace this. So if application listens to a port, as you know, it can use some functions for getting input, receive, or VSA receive. So I basically put a breakpoint on receive to trace the input. I just sent junk bytes, and then step by step, I trace the input. And when I sent some junk bytes, I saw that it gets the first 4 bytes of the data, the application listening a port. When it gets the data to that port, it compares first 2 bytes with DD bytes. So if the first 2 bytes of incoming data is equal to DD, then it jumps to switch cases. So we understand that we should send a packet to the application which starts with DD bytes. Then we pass the comparison and comes to these switch cases. And here the cases all have different jobs to do. Let's find the bugs. After I come to switch cases, I look at some strings used there, and I found a delete file vulnerability. Case 13 in the switch cases, as you see, gives you opportunity to remove file. So if you prepare a packet which starts with DDDD, and then if we call this opcode 13, we are able to delete any file from the system. And another bug was upload file. It was at switch case 6, and if we call this case, we are able to put any file to the SCADA system, upload any file. So these are very easy logical bugs in SCADA applications. So actually, what is wrong with that? These are actually included in the application as a feature, but these are dangerous operations for an application because there is no authentication for these operations. Just they compare some bytes and then we get in. So the developers actually should implement a authentication before calling these functions, but they didn't. So that's a vulnerability for us. And another interesting story that I lived. This is another SCADA product, Progy Movicon. I have discovered this vulnerability in November last year, yes. And there was more than one vulnerability in the software, but there was a very simple bug in the software. I can't sell it or I can't use it. It was just an information disclosure vulnerability. So I decided to publish it on Pastebin because I believe in full disclosure. You know, responsible disclosure is just bullshit. So I published it on Pastebin, and a few days later, ICS who works with SCADA vendors to coordinate page process of SCADA application, contacted me and asked details about this Pastebin report, and then I sent the information, okay. And after that, I get an email from my cert. The vendor says, we fixed this vulnerability 2 years ago. So they ask me, are you sure that this vulnerability works in the latest version? Maybe you find another way to exploit, but the vendors say this bug was resolved earlier. So actually I was worried that maybe I had older version of application, but then I controlled the old bugs and the report about it. Yes, my findings look exactly same, but I checked my version and it's the newer version. So I am able to reproduce these bugs on latest version. And then let's analyze the vulnerabilities. The bugs actually same to in CodeSys case. There was no authentication. So it listens a TCP port for incoming connections and packets. So if it sent a packet which starts these bytes, it just checks for first 4 bytes of incoming packet. And if it's equal, then there's a second comparison of application, and there's another comparison. It checks 5th byte of incoming packet and 6th byte. If we pass these also, then we come again to switch cases. And here, the information that disclosure vulnerability was opcode 25. If we call this opcode, it just call get version X API of Windows. And then it sends the output of this function to the client. So we are able to call this function remotely with sending a packet to the system, and then we are able to get info about system. Is it Windows version, about Windows version or something like that. So this is a bug right now, but we must exploit it. Here is a simple exploit for this bug, just sending a few bytes, and then we get return values of get version X API. Here is when we run it and call opcode 25. As you see, these are return values. And for example, this 6th byte says it is major version of get version X API, and it gives information about the operating system. Is it Windows 7 or Vista? This kind of information this will want. But as we said, they say we patched this vulnerability 2 years ago, but we are able to exploit it in. So what's the problem here? Then I downloaded the older versions of this product, and I just made some comparison diffing, and actually they didn't fix any vulnerability here. They just changed opcodes of switch cases. So for example, in the older version, opcase 7 was responsible to call get version X API. I think the vendor thought that, hey, hackers discovered this opcode, so we can change it. So in the new version, just they changed opcode 7 to 25. So we were able to reproduce this bug again. So this is a face palm for this vendor, right? Actually, they should have to implement an authentication instead of the changing the opcodes. And another vulnerability discovered by me in CodeSys again, that's a web server of application for visualization. Yeah, I said correctly. It opens the SCADA system to internet for checking it remotely from your home or office. And that's, that application, the web server, has amazing vulnerability. If you send a long GET request to HTTP server, it just calls SPNTF to print it in the logs, and then, as you know, SPNF is an unsafe function, and it causes buffer overflow. And Mr. Fadley yesterday told about this SCADA systems. They are really old, using Windows XP or more older operating. So this is buffer overflow vulnerability, but you even don't need to fight against DEP or ASLR protections. So very easy to exploit. And another vulnerability in Schneider SCADA application, and this was used in Czech Republic, gas distribution, and I think I canceled them. Actually, I don't cancel, but before I was in another conference and they wanted me to hide these informations. Also traffic center and I think Malaysia airport. And this was a denial of service vulnerability, not much pretty, and just a simple bunch of codes is able to cause denial of service in this application. Another Schneider Electric application vulnerability. This is the same with CodeSys web server. When it gets long GET request or POST request, then buffer overflow happens. Because of, as you see here, it gets the request, and then it calls strcopy function. In modern applications, it is hard to find these unsafe functions, but SCADA systems are really good for that. Case 6, poll-linked operator. This is another vulnerability discovered by me in Invensys SCADA application. I think it's a part of Schneider Electric also. I just discovered it was an ActiveX vulnerability. I just fuzzed ActiveX contents. You know, there are many ready-to-use fuzzing tools for that. And then I found a vulnerability in one of these applications. But it was used, this ActiveX component was used in many applications, so I killed 5 birds with one vulnerability. So, as you know, ActiveX one exploit works on browsers, so you need to send exploit URL to operator. If he click, then we will get him. Another vulnerability, this was discovered by another researcher, not by me. In the soft HMI box, this in the soft also a part of Schneider Electric. And as we understand from the title, this vulnerability is same as CodeSys and ProG applications. There are some operations which are remotely triggerable, and there's no authentication. So I just reversed the application and found which operations it has. And this is the simple exploit for this application. If we send 15 opcode to the application, we are able to remove a file on the system. We are able to remove a directory with this 10 Xcode, and then this is very interesting. We are able to load a DLL to the application. So we can first send a file. Also, there's a send file operation. We can prepare a malicious DLL. We can send it first to system and then load it to the application. Then we will get a shell. That's just so easy, as you see. What about targets, finding targets? Many SCADA operators claim that SCADA systems are not open to internet, but this is the web server. I found bugs, CodeSys web server, and when I just search it on Shodan, here is the results. In Shodan, there are nearly 700 results, mostly in Germany, France, Austria, and Italy. And some of them vulnerable, some of them not, because I've discovered it many years ago and I think it was patched. And real-world SCADA systems. Do we really need to reverse the applications and do vulnerability research for hacking SCADA systems? Sometimes no. Mr. Falde yesterday talked about this. There's many weaknesses in SCADA systems, as we know. Here is a bonus. This is another SCADA application, widely deployed on internet and open to remote connection. It has a FTP server, and nearly all of them we are able to log in with anonymous account. And the most interestingly, we are able to create, delete, and read the files with anonymous account. We have very good privileges, as you see. And as you see, when we enter the system with anonymous account, there is internal storage directory, and there is an auto-exec here. So an example attack scenario, just upload your malware and edit the auto-exec, and after a reboot, game over. That's all. So thank you for listening. Do you have any questions?
There was like a talk by the guys at Digital Bond at S3 Japan a couple of months ago or a month or so ago about CodeSys version 3, because there were some vulnerabilities related to unauthenticated communications in CodeSys version 2. CodeSys is a runtime framework that is used by many other vendors.
Yes, exactly.
And it turns out that they've issued a patch for CodeSys version 2, but then the same issue happened in CodeSys version 3, showing that this vendor basically patched the issue in one of its products, then it came out with a new product that basically had the same vulnerability.
Yes, exactly. Most of, for example, as you said, CodeSys patched the vulnerabilities, but many other vendors use older CodeSys frameworks in their own applications, so they are still vulnerable to old bugs.
So essentially, in this case, it comes down to like the dangers of third-party code misuse.
Yes, exactly. Any other question?
No? Everything was
No.
clear? Okay,
Okay,
thank you
thank
so
you.
much for your presentation.